Hello everybody, we will explain in this series of videos about ATENA and GiD program for beginners. We will use ATENA program and GiD together. In this video, we will learn about GiD program, how to prepare the model. The GiD can be customized to create input data for basically any finite element software. So we should select from the main menu data, problem data, ATENA. This step must be done before starting input any data, because if we select this command later may cause losing of all material and load definition. Then we should change the title and task name files where the results of the analysis will be saved. By the command data, problem data, we will put in the title box shear beam and in task name 3D beam, then accept. Now we can start. Our example is simply supported beam which is loaded by two loads. We can see the beam is symmetric around its vertical axis. Therefore, only one symmetric half the beam will be analyzed. The geometrical model of this half beam is composed of three 3D regions, are called volumes. So we have three volumes, beam and a loading plate and supporting plate. Now we will draw the beam which is rectangle. So we will draw 4 points. The first one here, second points here, third and fourth point. We define the point by command geometry create point. Each point is defined by 3 coordinates x, y, z, which should be written in the command line. The first point 0x, 0y, 0z, we write all together and separate by comma. Second point 1.275, we use dot to represent a decimal point, then 0y and then 0z. Third point 1.275x, 0.19y and 0z. Fourth 0x, 0.19y and 0z. Now we can press the zoom to enlarge the model such that it fills the whole screen. Next step is to connect these points by lines by using the command geometry create straight line or by using this icon. After select the command, we should click on the right bottom of the mouse and by contextual, then join, or by clicking Ctrl and A at the same time. We see the mouse cursor will change to this shape. Then we can draw the lines. We will create a surface by selecting geometry, create, NURB surface by contour, or by clicking this icon. Then we should select all the lines and we press escape to complete the definition. Now we will create the volume from the surface by using the command copy, and this photo explain how copy work. Now we can select copy from utilities, copy. Now we should input entity type here, surface. Now this surface is extruded in the direction of z-axis by the thickness 0, 3, 2. Now we should select what the result should be. we select volume, then select the surface and finish. We can see this volume in 3D mode by clicking Shift and the left button of the mouse. We can make rotate by this button and rotate the shape, or by clicking Shift and the left button of the mouse and rotate. And we can move the model by clicking this button or Shift and right mouse, as we see. Now we should create the loading and supporting plates. We will use the command copy. The upper right edge of the beam can be copied and moved to 0.115 meter to create the first line of plate. Then we will copy this line distance 0.1 meter to create second. GiD, we should zoom at the right edge of the beam, then click copy lines, and in X axis minus 0.115 without any change, and we select the line and finish. Now we have the first line of the plate. The second line in the same way, from copy we should select line. Now X minus 0.1 meter, select and finish. Now we have two lines. We should connect these lines into a rectangle. So line, Ctrl A, and draw the line between these. Then create surface by command geometry create surface automatic. After we select automatic method, the program asks for the number of bounding lines. After definition of this number, the program automatically creates all possible surface with the given number. After that, we should extrusion the surface into volumes by using copy. We should select surface and height of the steel plate 0.03 meters, volumes, and we select the surface of the plate and finish. Now we have volumes. The bottom steel will be created by copying of the top plate. The coordinates are on X minus 0.81, Y 00, and on Z minus 0.35. We should select volume, and without a change, we zoom in to select the volume of the plate and finish. Now we have the bottom plate. Now we should define reinforcement bars by two lines. The first one, we should select line and input the coordinate of reinforcement. The first point has 0.05 on x and y and z, and the second point has coordinate on x 1.275, on y 0.05, and on z 0.05. The other line, we will draw it by command copy and put on y coordinate 0.05 and without change, and select the reinforcement bar and finish. Now we draw all the model. Next video we will explain how to define layers, materials, and loading. It's very important to press Ctrl A button when we want to draw a line, because let's assume that we want to complete this line in this point. We use line command and then draw the line. But if we zoom in, we will notice that this point and this are separate. But if we press Ctrl A, we cannot draw the line without a pre-existing point, so the program will not allow the drawing of new points, but it will only connect the points. We want to put the components of the model into different layer. This is done by command authorities layer. Now we create a new layer by this icon. It's named beam. We want to assign the beam to this layer by icon this, and we select also our entities, because the beam contains three types of entities: lines, surface, volumes. Then we select volumes. As we see, now we can deactivate the other layer to see only beam layer. Now we can deactivate the beam layer and make new layer name bars, and select the reinforcement bar the same way by this icon and lines. Then we select the reinforcement bar. Now we can deactivate this layer and create new layer for plates by the same way, the name plates, and we select volumes from this icon, volumes, and we select the volumes of two plates. Now we have three layers, one for beam, one for bar, one for plates. Now we can delete layer 0 and done. Now we want to define the materials. We have three different materials: concrete beam, steel plates, and reinforcement. We want to function the concrete beam, so it's good to display only the beam layer. Then we press the icon this, or by data materials salt concrete. It's important to copy the already existing material and save it under new name from icon new, then name beam. In this example we have to choose parameters of concrete class 20/25, and safety format should be mean. Then it's very important to click on the update change. In basic window, we should change the parameters like young models to 31720 and tension strength to 1.64, and in compression strength minus 25.48. Then update. Now We can assign the concrete material to the geometry by clicking on Assign Volumes. Then we should select the volume of beam and finish. We can make sure through Draw option we should see the beam has become green as we see, and close. Now we will assign steel materials to the plates. So we activate only plates layer. Then from data, materials, solid elastic. First, as we said, it's important to create new name from icon new. The name should be plate. Then we selecting assign volumes and we select both volumes of plates and finish. Then we can make sure by clicking on draw plate, then the plates will be colored. Now we will define reinforcement bars material by selecting this icon, or data materials 1D reinforcement. We should zoom in the window as we see. Then we select new. The name will be bars. The parameters of the new material bars are defined according to Eurocode 2. The characteristic yield strength should be changed to 560 megapascal, and the class of reinforcement should be changed to class A, and the safety format should be changed to mean, and update. Okay, close. Then in basic window, the calculator checkbox has to be selected to be possible to define profile. Then the profile diameter should be changed to 26 millimeter. Okay, then update. Now we can assign, we should select line, then select the bars. Okay, we select the bar, then finish. To be sure, draw bar, we see the green. The icon draw all materials can be used to check if all materials are correctly assigned. As we see, the analyzed beam is supported at the bottom steel plate in the vertical direction. The support condition should be applied to the line, and this line has to be added into the bottom plate, so we should divide the bottom plate surface by this line by command geometry edit divide surface num division, as we see, or by clicking this icon. Then we select the surface. For easy choice the surface, we can use render, from render flat to change the model to this, and now we can use the surface. This dialog means in which direction we want division. We have to access U and V. We use U axis, then the number of division should be number 2, then OK. Now we have the required line. We can go back to the basic form by using render normal. Now we can see the line which we want. Now we can add the support condition by this icon, or by the command data condition. The support should be applied on line. So we should select line, then constraint line. Coordinate system will be global. The support is in vertical direction. The Z constraint has to be selected in order to prevent any rigid displacement. Y constraint should be selected. Then assign. Now we should select the line and finish. To be sure, from draw line, the line will be colored. And okay. Now we will define the displacement on the top plate. This load should be applied on a point in the middle of the plate. To draw this point, we will divide the top surface into two surfaces, and then the line will be divided into two parts. So we can divide from geometry divide surface, as we said, and norm surface. We will change to flat from render and choose axis. We choose U axis number 2, and we have now the line, and we will divide this line into two parts. Divide line, line and number 2, and we select this line. We can go back to basic form from render, normal. Now we see the point which we define the displacement by this icon. We should select the displacement for point, and the displacement is in vertical direction, therefore Z displacement should be defined. The value should be minus 0.001. Then assign, select the point, should be careful, point, and now finish. To be sure, draw color, we okay, and close. Now if we click on this icon, we can see the loads and supports. Only half of the beam is analyzed because it's symmetrical, so the horizontal X displacement along the right side should be 0. We define this by this command. The condition is applied on the surface, so we select surface, then constraint for surface, X constraint, then assign, and we should select this surface, the right side, and finish. And to be sure, we can use draw color, and we see the surface. In each model, we should define monitor's point. In this example, two monitors will be defined. One will be monitoring loads on the top plate, and second one will monitor deflection in the middle of the beam. We will define the first monitor point by this command. Then we should select point and monitor for point, and in this command the option reaction has to be selected. The monitor point will monitor reaction in the Z direction. Then the name of the top plate monitor will be load, assign, and we should select this point, finish, and to be sure, draw color as usual. The second monitor point should be located at the middle of the beam by the same way, but we should select output data displacement, and monitor name should be deflection. Then assign this point and finish. By this command, we can see all the loads, supports, and monitor points. Now we would speak about intervals. It's the loading history and load steps. It can be prescribed by selecting data, interval data. This box means there's a predefined displacement 0.0001 meter on the structure in this interval. This means that's necessary to increase the prescribed displacement approximately 40 times to reach the failure of the structure. And this box means The interval will be divided into 50 load steps in this case because the load shouldn't be applied to the structure in one moment. Then check this box and accept and close. Always we generate mesh in the last step. We can generate it by generate mesh or by pressing Ctrl and G by the same time. Then OK, this box will be appear and the mesh will be generated. Demo version of ATENA is limited to 300 elements in mesh, and this mesh, as we see, contains almost 3000 elements. So for users who use demo version, you should create new mesh, and this new mesh will be for the beam volume. The finite element size should be 5 elements over the beam height and 2 elements over the beam width and 16 over the beam length. We can do it by command mesh structured volumes assign. Then we select the volume, then we put the first number is 16 and select the length, then 5 and select the height, then okay, and then number 2 and select the width. Okay, then close. And now from mesh element type should select mesh element type hexahedra. Now we select the volume of the beam and OK, or escape to OK. And number of linear elements, as we saw, 38. It means the reinforcement bars were also divided. It's not necessary and it's better to reduce number. The same way from mesh structured lines, assign number 1 and select the 2 bars. Now we can generate new mesh as usual, Ctrl G and OK. Now we will start with nonlinear analysis by using ATENA program by clicking this icon. Now the program will start to generate the input file for each step of nonlinear analysis. This is a program. If there's a problem with the model, the analysis may end with an error at the very beginning, as we see. If it's not clear from the error or warning message how to correct the model, it frequently helps to look for a solution explanation in ATENA troubleshooting manual. In this case, we can back to GiD and change the solver by program data, solution parameters, and we can change the solver to LU. Now accept and we will back to analyze again. As we see, the problem is solved. We can see top plate distorted and shifted during step loads and without any change in the beam. So this analysis is wrong, and it means that no connect between plate and beam. In ATENA, the connecting independent surface together is called fixed contact, which distinguishes master and slave conditions. In this example, the beam surface will be masters and plate will be slaves. In other videos, we will explain how we can decide which will be master and which will be surface. Now, by using this icon, we can switch between mesh view and geometry view or render normal. Now this command, we can select surface and fixed surface or fixed contact. Now the name master, the name top, and for easy surface selection we can change to render flat and select the surface, beam surface, and finish. Now we should select slave, but the name should be the same. Slave and master should be the same name, otherwise the beam and plate wouldn't be connected. Now we can deactivate the beam layer and select the surface of the plate. We should be careful and finish. We can be sure by color as usual. We can see the color. By the same way, for the bottom plate, surface and fixed contact, master for the bottom surface of beam, the name bottom, and assign to be easy, render, rotate, and this surface should be select. Now slave, assign, can deactivate the beam layer and rotate. This surface should be select. And now by using color we can be sure by this color, and by clicking on this icon we can be sure which surface is fixed. This sentence will appear on the fixed surface. Now we should generate a new mesh by Control G or by this command, and analysis to go to ATENA program. We can see a lot of windows. This contains analyzed steps and iterations. This contains important message from ATENA kernel sent during analysis. This contains setting for displayed results, and this contains progress of analysis, number of steps and iterations, and this box contains graphical representation of the analyzed structure, and this contains default convergence diagram or other user defined diagram. During the running analysis, it's very useful to see the evolution of the applied load and beam deflection. We can make the diagram by clicking on this icon. The diagram title can be LD, load and deflection, and horizontal axis should be displacement, deflection and displacement. The name of axis displacement unit meter. We can see in the left side the changes, and vertical axis should be load reaction. We can change the title from here. Title, we want put load and unit meganewton. As we see the change, and we can switch the side of axis, and we have now this diagram. To better view, we can change the width of the line as we see. By this icon, we can edit properties of this diagram. We back to the same window. We can maybe change the color. As we see, each step appear on this line, and this we can pause the analyze, and by this button we can interrupt this analyze and OK. If we want to restore the original windows, we can use window default, and we can switch between the windows from here. We can also display crack width. First we will use this icon and select 3D, then click to this icon. Now from the results, show scalar results and value crack width should be selected, and item code 1 because there's at most 3 cracks at each node. Now draw ISO area and apply. For better view we can rotate the model as we see, and rotate by shift and left bottom of the mouse. For better view also we can display deformation as we see model change. Also cracks can also be displayed on the surface. From here crack maximum 3 and minimum value 0.0005 maybe, it's good, and apply. As we see, crack appears on the model. All of these options of drawing cracks and results on the structure are in fact post-processing features of ATENA Studio. This is one of unique features of ATENA software. Now, after the nonlinear analysis finishing, we can click on post-processing and make new structure windows by this icon. For better view, we can rotate the model, and from this icon we should select 3D. Then we will see how the crack appear in ATENA. So from crack here, show cracks, and the maximum level should be 1 to see better, and from results show scalar result and value crack width with code 1 and draw ISO area and apply. Now from set properties we should select element transparency. As we see, we can reduce the minimum of cracks and rotate the model. In this way we can show crack in the best possible way. As we see, it's nice view. Now we want add new window to show the reinforcement bar. Reinforcement to 1D, not 3D, and we don't have 1D, so we should add from edit activity and add 1D. The name should be 1D, and we select it from this table and OK. Now we have, so select and select draw all the model, then we can go to results to show the strain. Okay, we select strain axis and apply. For better view, we can change from edit properties the elements width to 6 maybe. It's better to view. And here in step 31 the load was maximum, so we can go to step 31 by this and show the strain in reinforcement bars.